let's talk quickly about parallel and perpendicular lines. If you have ever thought about or heard about parallel and perpendicular lines, you can see these are the pictures that I have at the top of the page. The ones on the left, these are parallel lines because they run side by side like railroad tracks. They never touch. So parallel lines never touch. Perpendicular lines are lines that cross, so they touch, but they're special because they touch, and the angle that they make when they touch is a right angle. And you may or may not remember, but a right angle measures 90 degrees. So perpendicular lines meet at a right angle. So they can be tilted in different directions, but if they're perpendicular, they meet at a right angle. So if you have parallel lines, you also are going to have lines that not only do they not touch, but they have the same slope. So if one of your lines has a slope of 2, the other line has a slope of 2. If one of the lines has a slope of negative 3/4, the other line has a slope of negative 3/4. So parallel lines have the same slope. For perpendicular lines, their slopes are negative reciprocals. What in the world does that mean? Well, that means that there are inverted opposites of each other. So if you have a line that has a slope of 1/3, the negative reciprocal of that would be negative 3/1. You flip the fraction over and change its sign. So if we have, let's fill in the blank. If lines are parallel, then let's put slopes are the same. Okay, if lines are perpendicular, then slopes are negative, I'm going to abbreviate that, reciprocals. So let's look at the kind of examples that they're going to give us. Suppose you have a given line that has a slope of negative 2. Find the slope that is parallel to the given line. Well, it would be the same. So it would be a negative 2 if it's parallel. If it's perpendicular, the given one is negative 2/1 if I want to write that as a fraction. So if I want to get the negative reciprocal, I need to flip it over, 1/2, and I need to change its sign from negative to positive. So I'm flipping it, and then I'm changing the sign. It started out a negative 2/1. The perpendicular line will be positive 1/2. So suppose a line is defined by the equation x equals 2. What is the slope of the line parallel to this line? Well, let's think about that, and let's just draw a little sketch over here. If we have the equation, and we have a line that is x equals 2. If you'll remember, x equals 2 means we're going to have vertical line at x equals 2. So that's on my x-axis. So the slope of the line that's parallel to this one, this has an undefined slope. So its parallel line is also going to be undefined. Okay? Suppose a line is defined by the equation y equals 3. What is the slope of the line perpendicular? So again, let's just make a little sketch. If we're doing y equals 3, then I'm coming up here on 1, 2, 3, and that's going to be a horizontal line. Its slope is 0. The slope of the line perpendicular, if I'm going to, I'll just draw it in red, if I'm going to draw a 90-degree line to that one, it'd be going straight up and down. Its slope would be undefined because it would be going straight up and down a vertical line. Vertical lines have undefined slopes. So a line has a slope, m equals 3. So this time you've got to read the questions carefully. A line has a slope, m equals 3. The slope of the line perpendicular to this line is what? So m equals 3 I'm going to say 3 over 1. So to find perpendicular, flip it over. So 1 over 3, then change its sign so it goes from positive to negative. Okay? In the following examples, information is given about two different lines. Use the slopes to determine whether the lines are parallel, perpendicular, or neither. So they're either going to be the same, they're going to be negative reciprocals, and if they don't fit one of those, then you have to say neither. Okay, but we're going to see if they fit one of those areas. So if we've got a slope that has a 4 for one line and a negative 1/4 for the other, those are negative reciprocals. So they are perpendicular. Alright, here we've got slope that is a 1/3 and one that is 2/6. Well, I recognize that 2 over 6 is not reduced. That'll reduce by 2's. 2 goes into itself 1 time, 2 goes into 6 3 times, 1/3. I end up having the same slope. Even though this was not reduced all the way, I can reduce it all the way. They're the same slope, so they are parallel lines. Alright, the next one, I've got 3/4 and 4/3. Now, that is flipped, so I would almost think it might be perpendicular, but my sign didn't change. My sign doesn't change. So even though I flipped them, if I don't change that sign, then it can't be perpendicular. So this would be one where I would answer neither. Okay, let's try these at the bottom. Use the slopes to determine if the lines are parallel, perpendicular, or neither. Here's another one where I've got 4 over 6. I can reduce that by 2's. That reduces to 2 over 3. So I have 2 over 3 and 2 over 3. That means that they're the same, so these are parallel lines. Okay, the one underneath it, you've got 2/9, and then I've got 9 over 2 with a negative in front, so I flipped it and I changed its sign. That makes it perpendicular. And there's a little bit about parallel and perpendicular lines.